So up until this point, we have learned about forces and how forces, if applied to an object, cause an object of a certain mass to accelerate, either linearly or in a centripetal form of acceleration. So now we are going to start to talk about how motion of an object and force of an object are related to the energy of that object. So, in order to get an object to move, a force has to be applied, and the force is applied in the form of work. So, a force is applied in the form of work. Right? And when work is applied to an object, there is energy transferred to that object. So, work transfers energy to the object. Right? So this idea, this interrelationship between work and energy is called the work-energy theorem, and I'll talk about that here in just a second. Right? So how do we actually calculate work? Work is equivalent to force, and it's force parallel, so we use a little sign like this, to the distance. Right? So the unit for this is newtons times meters, but it's also known as joules, or J for short. So if I wanted to calculate the amount of work done in an object, let's say I exerted a 10 Newton force and the object were to move 2 meters, then it would just be that the work would be 20 Newton meters or 20 joules. Now, if I were to apply a force, let's say at an angle here, let's say the 10 newtons was applied at an angle of, let's just make it 60 degrees, and I move the object 2 meters, I would have to actually find the component that of the force that was in the plane of the motion or was parallel to the motion. So the cosine of 60, which is 1/2 times 10, so that gives me 5. So only 5 newtons of force would be with the plane of the motion. So in this case, we'd have energy of 10 joules or 10 newton meters. Right? So the idea that work is related to energy is the work-energy theorem. So work is actually equivalent to energy. These terms can be used interchangeably. All right? And that's why they have the same unit. The unit for energy is joules, and the unit for work is joules. So in the next video, I'll go more in detail about what energy actually is and how to quantify energy of different forms, whether it's potential energy or kinetic energy. The last thing that I do want to talk about in this video is power. So power is the rate of energy change or of work. So the rate of energy or work. And anytime you see this word rate, that means that it's that over time. So power is equal to energy over time, or it's also equal to work over time. Right? So if I was going to plot this graphically and find a slope, I could plot either energy or work, and time on this axis, and then the slope of the best fit line would give me power. Right? So the unit for power is joules per second. And this is actually called a watt. Right? Now, I kind of want to take a look at this equation and show you just another way of writing it. So I just told you that work is equal to force times distance, right? And now we have power is equal to work over time. So if I were to plug this in here, I could derive the equation that power is actually equal to force times distance over time. And you should recognize by looking at this that d over t is actually velocity. So we can also calculate power by taking force times velocity. All right, so hopefully this will get you started on starting to look at work, the idea of work and energy and power, and then in the next unit or in the next video I'll discuss specific types of energy and how to quantify those.